Networking is the backbone of ethical hacking, forming the foundation that every hacker needs to understand in order to identify, analyze, and exploit security weaknesses. Without networking knowledge, an ethical hacker would be blind to how data flows, how systems communicate, and where vulnerabilities exist. Networking plays a role in every phase of ethical hacking, from reconnaissance to exploitation and reporting. Networking matters in ethical hacking because it allows hackers to understand the IT infrastructure they are testing. A network is like the nervous system of an organization, interconnecting devices, applications, and users. Ethical hackers need to grasp how these components interact to uncover potential weaknesses, such as open ports, misconfigured devices, or weak protocols. Every device on a network represents a possible entry point for an attacker, and understanding data flow enables hackers to determine where they can intercept or manipulate information. Protocols and services often contain misconfigurations, which ethical hackers can test to gain unauthorized access. IP addresses and subnetting are essential concepts in networking. An IP address is a unique identifier for each device on a network, allowing them to communicate. IPv4, such as 192.168.1.1, and IPv6, such as this address, are two common addressing schemes. Subnetting breaks a large network into smaller subnetworks, making it more organized and secure. Ethical hackers use IP addresses for reconnaissance, mapping out a network to identify targets, while subnetting knowledge helps in firewall testing and access control assessments. The MAC address, or Media Access Control Address, is a unique hardware identifier assigned to a device's network interface. It operates on the data link layer of the OSI model. Ethical hackers use MAC spoofing techniques to change their MAC addresses and bypass certain network access controls, which can be useful in penetration testing scenarios. Protocols define how data is transmitted over networks. TCP, Transmission Control Protocol, ensures reliable, connection-oriented communication, while UDP, User Datagram Protocol, prioritizes speed over reliability. HTTP and HTTPS manage web traffic, with HTTPS adding encryption for security. FTP and SMTP handle file transfers and email communication, respectively, and often contain vulnerabilities that hackers exploit. SSH provides secure remote access by encrypting communications. Ethical hackers scan networks for open TCP/UDP ports to discover active services and test for vulnerabilities, and protocol analysis helps them identify weak configurations. The OSI, Open Systems Interconnection, model structures networking into 7 layers: physical, data link, network, transport, session, presentation, and application. Each layer has its function, and ethical hackers use this model to locate vulnerabilities at different points. For example, weak encryption at the presentation layer or misconfigured transport protocols can create security gaps that hackers can exploit. Network devices such as routers, switches, and firewalls play critical roles in securing and managing traffic. Routers determine the best path for data, but misconfigurations can expose internal networks. Switches connect multiple devices within the same network and operate on the data link layer. Firewalls filter incoming and outgoing traffic based on predefined security rules. Ethical hackers test firewall configurations to check for weaknesses and analyze traffic through routers and switches to locate potential attack points. Network address translation, NAT, and port forwarding are two networking concepts that impact security. NAT allows multiple devices to share a single public IP address, which can complicate an attacker's ability to target specific devices. Port forwarding, on the other hand, redirects traffic from one IP and port to another, making internal services accessible externally. Ethical hackers analyze these settings to identify misconfigurations that could expose sensitive systems to unauthorized access. To perform network-based ethical hacking tasks, various tools are used. Nmap, Network Mapper, is a powerful tool for discovering networks, scanning ports, and identifying services. Ethical hackers use it to locate open ports and determine which services are running on a target system. Wireshark is a packet analyzer that captures and inspects network data, allowing hackers to analyze traffic patterns and identify security issues, such as unencrypted, sensitive data. Netcat is a versatile tool used for reading and writing data across networks. It can serve as a port scanner, banner grabber, and even a backdoor. Metasploit Framework is an advanced penetration testing framework that automates exploits and includes payloads for testing vulnerabilities. TCP dump is a command-line packet analyzer that captures raw network traffic for analysis. Ethical hackers rely on several key networking techniques in their assessments. Reconnaissance is the first phase of an ethical hacking engagement, where the hacker gathers information about the target network, identifying IP ranges, open ports, and active services. Packet sniffing involves capturing network traffic using tools like Wireshark or TCP dump to monitor data patterns and find sensitive information. Port scanning with tools like Nmap helps locate open ports and their associated services, which can indicate potential attack surfaces. Man in the middle MITM. Attack simulations test how secure a network is against interception and manipulation of traffic. Networking is fundamental to ethical hacking, providing the necessary knowledge to understand, assess, and secure an organization's IT infrastructure. By mastering networking concepts such as IP addressing, protocols, NAT, and network devices, ethical hackers can conduct thorough security assessments. With the right tools and techniques, they can identify vulnerabilities and recommend protective measures to strengthen network security. This knowledge is essential for anyone looking to become an expert in ethical hacking and penetration testing.